Good morning. Oh, okay, Asha. What are you watching? Oh, that's cool. You have family in Jamaica. How fun. Yay, Ellen. All right. Well, I am going to the originals. Okay. I actually have started watching Vampire Diaries. I started a little while ago, but I haven't quite finished it. But it was pretty good. Alrighty, so let's go ahead and get started today. Oh, cool. You went to the record store and you're making a brown butter almond cake. That sounds really good. You saw your sisters. How fun. Yay. Well, it sounds like y'all had a good weekend. I had a good weekend too. Let's see, what did I do? Saturday, we went to some friend's house. And yesterday, I took my son to go bowling, and then we went to Top Golf. So we just had a little adventure day. It was really fun. So, welcome back, everyone. Thank you for joining us. All right, I'm going to go ahead and the Bitmoji is me, but now I have longer hair. All right, so last week we briefly talked about domain and range in functions. And so I would like for you to list out in the room chat the domain, the numbers that are in the domain, and the numbers that are in the range. I'm going to give you a second to do that. For those of you who maybe need a little reminder, actually, I wonder if I have this. I am going to, let's see if I can. Yeah, no, Elijah, you were right. 2468 is your domain. That's right. Very good. All right. So domain is our X value. So one way to think about it is, so we have an ordered pair, right? X and then Y. So in the alphabet, right? Everybody knows the ABCs. X comes before Y. And if we think about the words domain and range, domain or D comes before R. So I don't know if that helps anybody, but if it does, great. You can use that. So I'm going to go ahead and highlight the numbers in my domain. So that would be 2, 4, 6, and 8. So we would say domain is the set of numbers which are 2, 4, 6, and 8. These squiggly brackets just mean it's a set of numbers. And then the range is obviously going to be my Y values. So I'd have 7, 11, 15, and 19. Real quick, I'm going to let y'all write this down. I got to switch over to my whiteboard, but this is kind of a mnemonic device. Maybe if I can paste this image. So last week we talked about like input, output, domain and range, independent versus dependent variable. So this is Dixie and Royd. So Dixie is for you to remember that domain is our inputs, our X variables, or our independent variables. Okay, and then Royd, talking about our range, that's going to be our output or the Y variable, or in other words, our dependent variable. So I'm going to give you just a second to write that down or take a picture if that is interesting to you, or if you feel like that would help you. I know sometimes we don't remember which is domain, which is range, if it's X or Y. So I'm just trying to come up with a few ways to help y'all remember that. You don't have to use this, but for some of you, that may be a really great way and an easy way for you to remember it. For some of you, you might just remember that domain or the letter D comes before range and X comes before Y. So that is totally up to you. I'm just going to give about 30 more seconds if anybody is wanting to copy that down. Hey, Richard, do you have a question or you just have your hand raised? Okay, what's your question? Oh. Okay, go ahead.
I had just finished typing out a nice, beautiful poem when you closed the web chat. Why did you do that?
Because we're going to talk about math now.
It was a math poem, Dixie Roy, by Richard Dallas. A great way to remember your formulas, and it'll get stuck in your head. I spent years writing that. It went through 16 different publishers before finally making it here, and you turned off the chat just deleting it.
So sorry. Well, I just want to be able to give everyone some time to work at the end, okay? Alrighty, guys. So that's just kind of what we've gone over so far, just identifying domain and range. That's all what we talked about last week. Okay, so let's go ahead and talk about today's target. So today we're reviewing domain and range of linear functions. We're also going to talk about exponential and quadratic functions. So we're working today on identifying domain and range from a graph. And it's going to be, your answer choices are mostly going to be given to you in what we call interval notation. And so we're going to work with those inequality signs from last unit. The less than or greater than, or less than or equal to, greater than or equal to. So as you can see, a lot of algebra, it all builds on itself. So that's why it's really important that we don't get too far behind in watching your lessons in the course or doing your homework, because if you're not doing the work from unit 1, you're not going to be able to do unit 2. Okay, so we're going to work on that so that we can correctly state the domain and range, and we're going to do some practice problems. So a quick little review. How does this relate to what we've been learning so far? The domain and range of a function. The domain is the set of all the values of the independent variable, or the X coordinate. The range is the set of all the values of the dependent variable, which is also the Y coordinate. So domain, the set of all first values of the ordered pair. The range is the set of all second values of the ordered pairs. And we talked a little bit about this last week, but we're used to seeing our ordered pairs written out as just regular X, Y. And if you remember back to our like Dixie Royd little visual, we can write it as other things. There's other ways to represent X and Y. So we could write X and Y as domain and range, X and Y, input and output. And then we talked about this one last week, X and F of X. Okay, so I just want you to understand that all of these different words here, domain, X, input, those all mean X. Just another way to say X. Range, Y, output, and F of X are just various ways to say Y. So prior to algebra, we've mostly been just using X's and Y's, but now we're going to start using some other words, phrases to represent that X value and the Y value. So the domain of a function is the set of all the X coordinates in the function's graph. So what I'm going to do, this is a graph given to me, okay? My graph, I'm going to highlight it in green here so you can see. I'm first looking for, as this has said, the domain. So I am going to underline the x-axis. That's the horizontal one. Okay. I don't care about anything over here right now. Okay. The y values, I don't even need to worry about them because I'm only looking for a domain right now. So I go to the very left side of my graph. Let me circle it here. This point, it's a closed circle, which means it's going to include that number. I think that the thing that gets people tripped up is when you're looking at this, your eye tends to want to just go directly over to the y value. But remember, we're talking about x values. So I come straight down, and this value is 3. Okay, so I'm going to put 3 is less than or equal to. The reason I'm using less than or equal to is because this is a closed circle at the end of my function. Then I'm going to put x because I'm talking about domain. Now I need to go, I'm going to follow along my function here. Follow, 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 follow. Here's the endpoint. It's also a closed circle at 12. X equals 12. So I'm going to put another less than or equal to sign and put 12. So what this means, this right here, is x in the middle. X is greater than or equal to 3, but less than or equal to 12. So every number between 3 and 12 on my graph is included because it's a straight line, it's continuous, there's no gaps, there's no holes. So the domain of this function is numbers between 3 and 12. And sometimes some of you I saw in your homework were using the word inclusive. Inclusive means it includes those two endpoints. Another way we can write it is called interval notation. So with interval notation, we would use brackets like this. And I would say if it's a square bracket, that means it's a closed circle. If it's a parentheses, that means it's an open circle. So this would be 3, 12, and a closed, like a square bracket on both sides. So that means my domain, I'd have to write domain, is 3 and 12 inclusive. Okay. Something that the STAR test will try to trick you on is they will say, what's the domain? And they will put 3 and 12, and they'll do something really silly and put a Y in the middle, or they'll say f of x. So when you're answering questions and you read your question and you see that it says domain, you can immediately eliminate any answer from your answer choices that has f of x or y. Okay. All right. So now this one, the range of a function is the set of all y coordinates. So now I'm going to be looking at these numbers on my y-axis. Some of you might find it helpful when writing your inequality to just go ahead and say, okay, what am I looking for? Oh, range. Okay. Let me go ahead and just make sure I get y right in the middle. So then on either side, on the left side, I'm putting my lowest value. On the right side, I'm putting my highest value. So I go to my function here. Let's highlight it in red. Again, this is the same exact line. So here's my lowest point, and it is at y equals 6. It's a closed circle. And then my highest point is at y equals 12. And again, it's a closed circle, so that's why I'm going to have that less than or equal to sign. Another way to write this would be using those brackets, and I would say 6, 12. Angel, that's a good question. So I think we're going to have a few word problems on here. Not the next problem, but the next 2 examples. And I'll help you with that. You can also go back and watch the recording from Tuesday's session last week. And we did a bunch of word problems with domain and range at the end. So to find the range in a word problem, you first have to plug in your x values so that you can get your range values. That's a good question. All right, so I want you to try to do this on your own. Remember the little trick I taught you. Find out what it's asking. Domain of the function. Domain is x values. So look at your answer choices here. There are 2 you can automatically eliminate. So I put a poll up. Remember, it's asking for domain. So we're just talking about numbers that are going left to right. Yeah, good. It's not going to be A and it's not going to be C. That's right. So y'all go ahead and try this one on your own. All right, so remember, guys, A and C, we know that we're going to eliminate those straight from the get-go because they have the Y in the middle. So it cannot be A and it cannot be C because it's asking us for domain. And we know that domain is x values. Good, Angel. So Angel says that it's not B because one is open and one is closed. Exactly. So if we were just using process of elimination and saying, okay, let's say you're on the STAR test and you're like, I don't really remember, but I do know domain is X. Okay. You could eliminate A and C. When we look at our graph, like Angel was saying, one of these has an open circle and one has a closed. So we're going to have two different signs. So that would automatically eliminate B as well. But if we just wanted to solve this on our own and then try to find our answer, okay, domain we know is X values. So let's go ahead and put our X in the middle. On the far left, I have an open circle. So I'm just going to put my less than sign. That open circle is at this value of -2. Then I go to my other endpoint, which is right here. It's a closed circle. So I'm going to do my less than or equal to sign. And that value is at 6. So that's how I got D for my answer. All right, so Angel was asking me, how do I know how to find the range of word problems? So this problem says the daily cost of hiring a plumber, Y, to work X hours on a repair project can be modeled using a linear function. The plumber charges a fixed cost of $80 plus the cost of $45 per hour. The plumber works a maximum of 8 hours per day. For 1 day of work, what is the range of the function? Okay, so we're talking about range. Before we even solve this, I want you to look at your answer choices. And in the room chat, I want you to tell me which two answer choices we can eliminate and why. So we want range, and range is Y values. Good. So A and C have X in the middle, so that cannot be, it cannot be those. Alrighty, so now I need to write out my equation for this current situation, okay? So I'm going to come up here to the top. And if we go back and read our problem said the daily cost of hiring a plumber, Y. So it's going to be Y equals it's going to be $45 per hour. So 45 times X plus the $80 just to come out. Okay. So that's my equation. Now, to find the range, I have to put in my domain. So this says the plumber works a maximum of 8 hours a day. So the max is 8. Okay, so my domain, my max is 8. He can work 8 hours. He could also work 0 hours, right? Like if he didn't go or he got there and didn't work, it'd still be $80 to have him come out. So I'm going to plug in 0 for X, 45 times 0 plus 80 is going to be 80. So I know for my range, the minimum value then is 80. And then I'm going to plug in 8 to get my maximum value. So 45 times 8 plus 80 give me 440. So my range for the cost of a plumber, I'm going to be paying him somewhere between $80 and $440. So I'm going to pay him at least $80 if he drives out to my house. And I'm going to pay him at most $440 because he's only going to work for 8 hours. He will not work more than 8 hours. Okay, so B is our answer. Exactly. Okay, so now I want you to try this one. This is asking for the range. So Angel, that's kind of like what we're going over right now, is you're going to have to write out the domain and the range. And then that's also what we talked about last Tuesday. And I think I sent out a help video. And there's, I think, 2 or 3 videos in the course on that also. So check those out as well. Okay, so most of you got this. You're doing great. Let's talk about, it says a set of weights includes a 4-pound barbell and 6 pairs of weight plates. Each pair weighs 20 pounds. If X pairs are added to the barbell, the total weight of the barbell and plates can be represented by this function, 20 times X plus 4. Okay, so the 6 pairs of plates, that represents our domain. That's what we change. We change how many pairs of weight plates we put on, which then changes the total weight, which is our range. So our domain, we have 6 pairs of weight plates, right? So I'm either going to put on 0. If I put no weight plates on, I just have 4 pounds. I'm either going to put 1 pair, 2, 3, 4, 5, or 6. So Angel, this is like what you'll be doing in your homework on 2.06. You're writing out the domain. It has to be whole numbers. The reason it cannot be from 0 to 6 is because if I have each pair of plates is 2 plates, right? I either have to put them on as a pair. No, you can't use that notation because the reason is I can't put on 1.5 pairs of weights, right? I have to put on either 1 pair or 2 pairs. Okay, I wouldn't put on 1.72. So you have to think about what we call it our practical domain. So in real life, what would I be doing? What would I put on, right? I'm not going to take a saw to my weight and cut it in half. or cut it to be 0.63 weights. Okay, so that's why it has to be whole numbers. So now it's asking me, though, for the range. Yes, but what we're saying here, Angel, is if 2 pairs of plates weighs 20 pounds, then they each weigh 10 pounds on each side, right? But you wouldn't just put on only 10 pounds because you just have a 10-pound plate. So you can't put it on your left side because then you're uneven on the right side, and you wouldn't lift weights like that. So when you put weights on, you put 2 on at a time. So you cannot just put 10 pounds on because you have 10-pound plates. So you would need 2 5s in that case, but we don't have that. So to find the range here, I'm going to plug in these numbers. So if I plug in 0, 20 times 0 is 0. 0 plus 4 is 4. Okay, then I plug in 1. So 20 times 1 is 20. 20 plus 4 is 24. Okay, and you can see how we're going up, especially if you can recognize the pattern, right? Every time you add another one, you just add 20 pounds. So I don't even have to keep plugging this in my calculator. I can just say, okay, 4 plus 20 is 24. Plus 20 is 44. Plus 20 is 64. Then 84. Then 104. Then 124. Okay, so then you would see that your answer is B. Questions about that? Okay, so now what we're going to do is we're going to talk real quick about exponential and quadratic functions and how we find the domain and range of those. You're going to see that it's very similar to the linear functions we were just doing on the graphs, but they can be a little bit tricky. So if this is called a quadratic. So quadratics look like a U or an upside down U. So one way that we wanted that you can determine, I can go back real quick, Angel, but for 30 seconds. So the next slide, what I'm going to do is I'm going to show you kind of a method, I guess you could call it, some steps that you can follow. Some of you may get it right away, and that's totally fine. Like, you don't have to do the long drawn out process, but if this helps you to stay organized, then it's 100% worth it. So number 1 says use horizontal and vertical lines to draw a box around the graph shown below. Make sure no part of your graph is outside the box. Be sure the sides of your box are touching the graph. Okay, so what we're going to do is I'm going to use a small line, but down here I'm going to draw a line through that point because that's the lowest point. And I'm going to draw a line here. That's going to be my right edge. And then I'm going to draw a line right over here and back down. Okay, if this helps you, great. So you're going to draw a box basically around the border. Okay. Okay, number 2, highlight the left side and the right side of your box. Here's the left side. Here's the right side. Record the smallest number and the largest number when looking at your box from left to right. So what that means is smallest number of the x values. X value, smallest number would be -3. My biggest number is 5. Okay, so if I want to write the set of x values, I can write it in interval notation, or I can write it as an inequality. So -3. Okay. These values are called the domain. So you can do this same thing when you are working with a linear function. If it helps you to draw the box around your graph, so that way you can clearly see left to right, what are my x values, then do that. That's totally fine. So this is just another way that we can find domain and range. Some of you might be able to just look at the endpoints and say, okay, I understand. I don't need to draw the box. But the box is very helpful and it helps you to stay organized. All right, so then at number 3 down here says use a different color and highlight the top and bottom. So when we're working with quadratics, the range is what can be the trickiest part because domain is easy. I just look at my endpoints. But with a quadratic, one of my endpoints will be max or min, right? It's the highest or lowest value. But then over here, my highest value isn't actually where this endpoint is. It's actually up here, which is why we boxed it in. So my smallest number is down here at this line, which is -70. And my largest number is right here, which would be 150. So my set of y values would be from -70 to 150. If you wanted to write it interval notation, if you like to write it as an inequality, you would have -70 less than or equal to y, which is less than or equal to 150. Okay, and then these are called the range. Y values, those are the range. Okay, so now I want you to try on your own paper. I want you to, we're going to write out what is the domain and what is the range. So again, if you want to draw a box around it, great. If you just want to move left and right first and then up and down, also fine. I want you to use whichever method works the best for you and makes the most sense to you. Sure, Isaiah, I can do it real quick. There you go. All right, so let's go back to this slide. So remember, domain is x values. So we're just talking for domain. I'm going to put a little red dot here. Oh, maybe I'll make it bigger. There we go. Values down here. So for my domain, if I write it in interval notation, it's going to be 0 to 4. Okay, or you could write it as an inequality. Good. For my range now, I want to find my lowest value. So this quadratic dips down to x equals, or y equals 1, sorry. And it goes all the way up to 5. So from 1 to 5. questions so far about this one? All right, so now what I'm going to do is leave you with this problem to do on your own. So there are 2 you could automatically eliminate. Okay, good. So a lot of you totally got it right in the room chat. You said, okay, get rid of C and D. And you're exactly right, because those say X. They have an X in the middle, and we want range. So this is the path of a golf ball. The only difference between A and B is just the inequality signs. So I want to ask myself, we're talking about the height of a golf ball in feet. A, with it saying that the range has to be greater than 0, it couldn't be equal to 0. That would imply that I'm always hitting the ball off the ground, right? And that's not true. If it's on the ground, it's not in the air at all. So it would be equal to 0, okay? For the second part of the 100, this is a line right here, and it's continuous. It doesn't stop. Okay, that's a continuous function. So it's going to include that value of 100. So B is the correct answer. Good job. Most of you got that right. Very good. Okay, this is kind of a tricky one. So first things first, the question is asking, what is the domain? So domain is talking about what? Are we talking about X's or Y values? Good, X values, exactly. So we can get rid of H because it has Y in the answer, and we don't want that. So here's where this is tricky. If I was going to write this on my own, I go to the far left side, okay? And I get to this point, which looks like it could be -3. However, what do you notice about the endpoint? Is it an actual point like we've been seeing? Good, Anya. It's an arrow, exactly. It keeps going. So that indicates we're going to keep on going. This doesn't stop. We just ran out of room on this coordinate plane. So this is going to keep going to -infinity, right? Because we're going to keep on forever. And then same thing when I go to do my value on the right-hand side. It looks like it ends at 2, but it's actually an arrow. So that's going to go to +infinity. So we're going to get all real numbers. It's going to be every number from -infinity to +infinity. Or you can write out all real numbers. Or sometimes they write it out like this fancy looking R. So the reason it's not J says all real numbers less than -3 or greater than 2. So that would mean from -3 to 2, we wouldn't have a function, but we do, right? It's still there. It's continuous. So that's why it's not J. And F It's not F because we have arrows on our endpoints. All righty. Well, that is